We're going to take another look at elimination and talk about when we don't have coefficients that are opposites. So remember, elimination method, we want to remove one of the variables or eliminate it by canceling it out in the other equation. But look at the system below. What is the most effective method to use? Well, graphing doesn't necessarily work because they're not an easy form to graph. And we don't have an isolated variable for substitution, so elimination is still going to be our best method. Find a solution to the linear equation. Any solution will do. Now, I just plugged in 2 for y and solved for x. So I have the point 7, 2. That's a solution to the linear equation. Now, multiply this equation by 3. Is the point above still a solution? Well, if I multiply the equation by 3, I get 9x minus 6y equals 51. And if I plug in my values for x and y, yes, this is the solution. 63 minus 12 does in fact equal 51. We can use the same principle to rewrite systems of equations. So we have equations with a variable with opposite coefficients in order to use the elimination method. Rewriting systems of equations. So, using multiplication, we can rewrite the system to make sure we have a variable with opposite coefficients. There are multiple correct ways to do this. So, for example, our first system is 4x plus 6y equals 10 and 2x plus 6y equals 20. We don't have variables with opposite coefficients. However, y's are very similar. I have positive 6y and positive 6y. So one way I could make those different is to multiply the second equation by negative 1. By doing this, now I get negative 2x minus 6y equals negative 20. And the first one stays the same, 4x plus 6y equals 10. And now I have opposite coefficients. Looking at our second example, I have 5c and 7c and negative 3d and positive 9d. Well, the ones that strike me as at least somewhat similar, I have a negative 3d and a positive 9d. Those should be pretty easy to get to be similar. If I multiply the first equation by 3, I get 15c minus 9d equals 39. So now I have negative 9d and positive 9d, and when I use elimination, I can eliminate the d's. The third example here is a little more tricky because nothing looks the same. I have 7w and 3w and positive 4z and negative 6z. Well, none of those are like, so how do I use elimination? One option is to decide one of the variables and try and get it to have like terms. So I look at 4 and 6. I know they both go into 12, so if I can make those both into 12, or one into positive 12, one into negative 12, I could eliminate them. So I'm going to do this by multiplying the first one by negative 3 and the second equation by 2. If I multiply the first equation by negative 3, I get negative 21w minus 12z equals negative 75. If I multiply the second equation by 2, I get 6w plus 12z equals negative 34. Now I have negative 12z and positive 12z, and they will cancel out when I use the elimination method. There's a lot of information on the screen, so take a second and look through it. You can also try other ways to make them have like terms. We didn't have to multiply by these values. We could have done it differently. Like I said, there are multiple correct ways. This is just one way for each of these equations. So let's put this all together. We're going to solve the system using elimination. So look at the first system. We have a and negative 4a and 2b and positive 5b. Well, none of those match. So in my mind, the easiest thing is going to be to multiply the first equation by 4. So I get positive 4a plus 8b equals 24. And when I add those together, the a's cancel out and I get 13b is 26. So b equals 2. Now remember, a solution is a set of values. We need the rest of the value, or we need to solve for a. So by plugging b is 2 in my first equation, I can solve for a. I get 2 times 2 is 4, so a plus 4 is 6, and when I subtract 4 from both sides, a is 2. My point is 2, 2. The second one, I have 5x minus 4x and 3y plus 5y. Well, again, nothing is really similar, but at least the x's are opposite values. One is positive and one is already negative. So let's try and get rid of those. Since 5 and 4 both go into 20, I'm going to make the x's both equal to 20x and negative 20x. So to do that, I need to multiply the first equation by 4. I get 20x plus 12y is 16. And multiply the second equation by 5. I get negative 20x plus 25y equals negative 90. Now when I add them together, the x's cancel out and I get 37y equals negative 74, or y is negative 2. When I plug y back into one of my equations and solve for x becomes positive 2. So my solution is 2, negative 2. Again, take a second, look through the math, make sure you understand it. And if you have questions, bring them to class. So now I want you to try solving these systems using elimination. Pause the video and give it a shot. Well, these two systems, I got the y's the same. You could have done it with x's, it's completely fine, but I multiplied by 2, the bottom equation by 2, to eliminate the y's. So I get x is 0, y is 5, my point of 0, 5. In the second equation, I decided to eliminate the y's. By multiplying both equations by 2, or multiplying the top equation by 2, I get negative 10y and positive 10y. So when I add them together, the y's cancel out. X is 4 and y is 6. So now we have three methods: graphing, substitution, and elimination. So when do you use which one? Well, graphing, you should use it when equations are in a form that's easy to graph, point-slope or slope-intercept form, and when you have an answer that is going to not be a decimal. Substitution is best used when at least one variable is isolated or can be easily isolated so you have it alone. Elimination, first of all, variables must be on the same side of the equation or can be easily moved to the same side. We talked about that. If the x's are on the left in one, they have to be on the left in the other. Also, equations must have a variable with opposite coefficients or must be multiplied by a value to have opposite coefficients. So when you can manipulate equations, you can use elimination. You're not going to use, unfortunately, graphing as the one you're going to use the least because you don't know if solutions are decimals or not, and so it's a waste of time if you graph it and you don't have an answer clear to you. So your best bet is to probably use substitution or elimination unless told to use graphing. Again, graphing may still not work if the solution is not an integer coordinate. So that's it. Now you know how to solve systems using three different methods. You can use whichever one you like, but some will be more efficient than others. Great job and well done.